We are taking software quality assurance under software engineering question and answer. What is the life cycle of a quality assurance process? So you see here, every process in quality assurance is all about putting standards and making it followed in your organization. So here we follow PDCA. So it involves Plan, Do, Check, Act. Plan, Do, Check, Act. So this is a cycle often also known as Deming cycle. So what are the phases? The plan. So the organization as a whole should plan and develop the objective, the process related objectives. Also the standards as well as the methods necessary to provide a high quality final product. So the quality assurance ensures that the planning made takes into consideration the good quality, high quality of the product. Okay. So the quality assurance is an organization level concept. We need to plan. Okay. Next thing is to do. So now this phase involves process development and testing, as well as doing changes to the processes. So here the quality assurance ensures that the processes followed during the development, it also maintains the quality of the product which has been laid down in quality assurance standards. Then we do the check. In this phase, the processes which are being standardized, these needs to be monitored, modified and checked. Why they are to be checked? Because we need to see whether they achieve the intended goal of quality assurance. Therefore, the quality assurance ensures that the processes are checked thoroughly so that no defects might be missed. Finally, the act. Okay. Plan, do, check and act. Here, quality assurance or quality assurance tester should take the step in order to improve the process. Whatever are the steps to improve the process, this is the task here in order to act. Now these stages basically they are guaranteeing that the organization procedures, the processes which are followed in the organization, they are properly assessed and they are also improved in a regular basis. You might have heard about CMMI, you might have heard about ISO 9126, the ISO 9000s. Differentiate between quality assurance and testing. So we'll see one by one. Quality assurance, under this quality control comes, under this testing comes. So quality assurance, this can be started at the project inception phase. So it is a part, you can say a subset of a software development life cycle. So better you start from start, it will be giving you a better quality. See, the testing is the part of quality control which comes under quality assurance. So it is a subset of quality control. So when we control the quality, the main thing is to test. So quality, in order to achieve quality control, we do the testing that corresponds to quality assurance implementation. So quality assurance is a process oriented. It is because we are trying to make the processes to follow the standards. And the testing is all about product. We are testing the product, the reviewing, inspecting the product. So it is product oriented. Testing is product oriented. Also the quality control is also product oriented. So we do all the kind of testing in software. We do black box, white box. Quality assurance is preventive in nature. Why? Because we say that these process has to be followed. So it is a preventive in nature. It tries to prevent defects from being present in the product. Testing is a corrective kind of a technique. So now, if defect is there in a developed product, we try to find out and we need to remove it. Quality assurance is done to prevent defects in the product. Testing is done to find and then remove or fix the defects in the product, because testing is followed by debugging, which is removing the error or the bugs. Quality assurance ensures that the processes and the procedures followed by the team are in place, which are being set in the quality assurance or quality plan. This is what you have to do. These processes have to be followed. So this quality assurance is when you can assure your stakeholders, oh, this is a quality product. While in testing, it confirms that the product conforms to the specification being required. The user's expectation are fulfilled here. In quality assurance, the focus is on the processes that operate on the product. In testing, we have talked about it is for end product. Quality assurance is proactive. That is, the proactive strategy focus on preventing problems from even arising. While testing is a reactive process. The problem is there, now we need to mitigate it. Quality assurance need to be implemented by the whole team because it is an organizational concept. In testing, a module or a combination of module or a product, everything, the testing can be done at these levels. So testing team is more to be concerned, the software team or the product team which has made this product. This testing team is mainly the key. Differentiate between test plan and test strategy. The one-liner answer is test plan is the implementation of test strategy. So test strategy is a bigger set. Test plan comes under it. In order to implement or execute the test strategy, we do the test planning. Okay. Test strategy are the set of rules that describe how to develop test and outlines how they should be carried out. That is the bigger abstraction level. So these are the guidelines, rules for a whole organization or maybe a big project. From inception to deployment, we have a common test strategy. This has to be done. The test plan, a software project test plan, it is a document. And it specifies what? It specified the intricacies. Even the scope, purpose and approach is there. But more emphasis is on the software testing actual process. In test strategy, we have following components. Objective. What is the objective? What is the scope? How will be the document formats? These are the formats you have to follow. What are the test methodologies? What you have to do? Black box, white box, smoke or sanity or whichever. Then the team reporting structure. Who is going to test? What is the quality assurance, quality control, the structure, client communication strategy. In the test plan, we have a document or a series of documents where we have a test plan ID because you are making a test case in test plan basically. So test plan ID, feature to be tested, the test procedures, the testing task, features, pass or fail criteria, the test deliverables, responsibilities, who will do what, the schedule, the timeline, etc. So test strategy is a general approach. Here general approaches are described in the test strategy. Here test plan is more specified. The specification of testing processes are described in the test plan and that is executed, that is implemented by the test cases. Finally, test cases are written. Now, the testing manager. So we are talking about test plan and test strategy. So test strategy, the project manager implements a test strategy, or you can say that the managerial level person do this. So it specifies which approach to use and which module to be tested. They can also prioritize it. While in the test plan, a testing manager or the lead executes a test plan that specifies how to test, when to test, who is going to test, and what to test. So here the level of abstraction is more detailed in test plan. In test strategy, it is very difficult to alter the test strategy because it is being created for the whole project or the organization. Test plan, the changes can be done. Okay, changes because if test cases are there, one test case is not good, you can remove it, you can add more test cases. So test strategy is a long-term approach. You can use information that isn't specific to a project to create a test strategy, because this is a broad view for different projects. Test planning is done to identify risk by determining potential issues and dependency, because here the test planning is done like that. Test cases are written like that. Okay, this may affect this one like this. Test strategy is frequently found as an element of a test plan in smaller projects. So in a smaller project, test strategy and test plan can be together. But test plan is individual. It can exist individually. In the test planning, it is established at a project level. That is, the test strategy is at the organization level and it can be utilized for different kind of projects. That is why I'm saying it is at the top level of abstraction. Explain the types of documents in software quality assurance. So software quality assurance is at organization level. It is all about processes to be followed, standards, rules, we can say. So these are the documents in the software quality assurance. The first one is SRS, Software Requirement Specification. All the functionalities, all the requirements are to be added in the application. These are documented in the SRS or the requirements, and the document is known as Software Requirement Specification. This requirement document is made in the collaboration with the stakeholders and the software team. There can be other people also involved, but they are properly signed by the two parties. Then we have the test metric. These are the quantitative measure. So testing the cyclomatic complexities and all these, this in order to determine the quality and the effectiveness of the testing process. There is metrics even for the testing, because the testing is also tested. The test cases are also tested. Then we have a test plan. So we make a strategy for the whole organization and there is a test plan for a project. It defines the strategy which will be applied to test an application, the resources that will be used, the environment in which the testing will be done or performed, and the scheduling, that is who will do, what will be done, what specific things are there, the resources, the environment, all these are there in the test plan. The test cases. So test cases are the final, test strategy, then test plan, then test cases. So the test cases, you can say these are the steps and conditions used at the time of testing. So here we want to check all the requirement specification, all the use cases, or you can say all the functionalities, that whether the software is working fine or not. So this can be various type of test cases. We have logical, functional, error, negative, positive, physical, UI, and functional and non-functional test cases. So we have boundary value analysis, we have multiple things, black box, test, white box, various. Then we have the traceability matrix. Now everything is done to make a project successful. It is coming from the requirement. So the requirement give rise to the design details and then the coding and the testing. So the testing, why it is done, coding, why it is done, design and why it is done, it has to be traced back to certain requirement. The traceability matrix is table that traces and maps the user requirement with the test cases. So the main aim of requirement traceability matrix is to see that all test cases are covered so that no functionality missed during the software testing. All the requirements, all the design, all the coding is properly tested, and this we can trace back to all the requirements. So there are RTM, the very important you can say document. Then the test scenario. This is a collection of set of test cases. We can have multiple test cases. So these test cases which are going to help the testing team to determine the positive and negative aspects of the project. Okay. So as I said, there can be multiple kind of testing. So this test scenario is sometimes also is the document which we refer in SQA. What do you mean by build and release in the context of quality assurance? Differentiate between them. So code, you write a code. Then if you are using in say Visual Studio or any kind of IDE, you build it. So this build you have made, it has not been tested. And then you release this. When you release it, that means it has been tested and now you release it. Builds can be multiple. So build is a software or an application that is ready to be tested. Developers, they create software, that is, they make the build and they hand it over to the tester to be tested. So this is a broad phrase that refers to any application that will be examined. The developers can either create a complete program or they can just add a new feature to an existing one and they can make a build. Then that program together with the new functionality is called as a build and it is put through its test by testers. Now what is release? After development and testing, the release is finalized application. The testing team verifies the program and releases it to the final customer end user after testing it. Okay, it's possible that a single release will have multiple builds. So as a result, it is the program that is supplied to the customer end user when the development and testing phases are complete. So the release is based on builds, and there can be multiple builds, but there cannot be multiple releases. Release can only be when one certain release or the delivery is planned. Let us see one by one also. Build is a version of the software or application which the development team hands over to the testing team. So build, whatever you make in your IDE, you actually make a program and give it to the tester to test. Release is the software which has already been tested and now it is ready to be handed over to the end consumers. The build version of the software requires testing to be done. So generally the sanity testing is performed on a build version, but there can be multiple testing. This is just an example. Okay. So sanity testing is, if you know the smoke testing, it is general health checkup. Sanity is proper organ checkup. So whatever has been changed or any functionality has been added, that is properly checked in this. This is a kind of build, that is, it is built over some pre-made build. Release is release version of the software. They don't require any testing. Build version of a software is made more frequently than the release version. Release version, because it is going to be released to the user of the software, are made less frequently than the build version because this is only delivered to the user and it cannot be made every day. You cannot deliver software every day to the user. What do you understand by bug leakage and bug release? Bug is a problem. Bug, the testing is done, the bugs will come. So bug leakage is, what is the difference? When the bug is discovered by the end user or the stakeholder or the customer that should have been caught in the earlier builds version of the application, a bug leakage occurs. That is, the bug you haven't found out, the customer has found out. You could have found out, but he has found out. So a bug has leaked from your end to the user end. So bug leaking is referring to a fault that exists during the testing, but it was not being discovered by us or a tester or a software team and is subsequently discovered by the end user. What is bug release? When we release, when a particular version of the software is released to the user with a collection of known bugs and defects, we know these are the bugs and defects in the software. It is referred to as the bug release. So bugs of this type are frequently of low severity or low priority. When the company can afford the existence of a bug in the release software rather than the time cost of repairing in that version, it is just released. So in most of the cases, these bugs are disclosed in the release note. It is properly given. Defect rejection ratio, defect leakage ratio. So defect leakage ratio is number of defects missed or leaked divided by the total number of software into 100. Defect rejection ratio is number of defects which are being rejected divided by the total number of defects raised into 100. Defect rejection ratio. What do you understand about traceability matrix in the context of quality assurance? So you see here traceability matrix. This is just a spreadsheet or a table. So every requirement gathering is followed by requirement analysis, and that corresponds and that results in a work product called software requirement specification. So this is the Bible, you can say, for a software team. All the requirements, whenever we test, because the requirement give rise to design, design give rise to code, code give rise to test. So every test should correspond to certain requirement. And this backtracking is called the traceability. And this can be done using a matrix like this, a row or column, where on the left you can have a requirements, on as a row, and on columns you can have test cases. So this is how you can backtrack and relate. The traceability matrix, you can trace the test cases to the requirement and vice versa. Okay, so this is the traceability matrix in quality assurance. So let me tell you again. Traceability matrix is a document. Normally it is a part of a certain document like the SRS also, or later part, the testing document. It is a documented that connects two baseline documents that require many-to-many link to ensure that the relationship is complete. It is used to keep track of requirements and making sure that they are being met on the present project. Okay, so there are three major components of traceability matrix, because every time you are making a design or the code, as I said, the testing code, the code and design should correspond to the SRS. So first one is the forward traceability. Second one is backward or reverse traceability. The third one is a bidirectional traceability. So forward traceability, this matrix is used to determine whether the project is progressing in the appropriate direction and for the correct product. So this ensures that each specification is applied to the product and each specification is adequately tested. So it connects test cases to the requirements, which you see in this diagram also. This is kind of forward traceability. And there can be the backward or reverse traceability also. So now it is used to verify that the present product is still on track. The goal of this form of traceability, backward or reverse traceability, is to ensure that we are not expanding the project scope by adding code, design feature, testing or other activities not stated in the requirement. So it also connects the requirement to the test cases. Previously, forward, test cases to requirement. Backward is connecting requirements to test cases. I hope you got the difference. Now, bidirectional traceability, this matrix ensures that all criteria are covered by test cases in both direction, forward and backward. So combine both forward and backward, you get the bidirectional traceability. It examines the impact of change in requirement caused by the defect, etc. What do you understand about defect leakage ratio in the context of quality assurance? So first of all, what is defect leakage? We have bug release also. Defect leakage ratio or defect leakage is what bug we have leaked, we have not found out, and it has gone to the end customer. So software tester utilized this defect leakage as a metric to determine the effectiveness of quality assurance testing. So this is the ratio of total number of flaws or problem attributed to a stage which are captured in subsequent stages to the sum of the total number of defects captured in that stage and the total number of defects assigned to a stage which are captured in the subsequent stage. So defect leakage is a metric that counts the percentage of faults that leak from one testing stage to the next. For example, 10 are there, 8 you have found out, 2 goes, 2 you have leaked. So how much you find out? 2 by 10 into 100. Okay, so the testing team's worth on the other hand is only confirmed when the defect leaking is small or non-existent or zero. What do you mean by monkey testing in the context of quality assurance? So monkey testing, now this is a concept. This is thought that a monkey, if something is given to this animal, then he or she will try everything. That is, this monkey testing is a black box testing, and this is employed to test the application by providing any kind of random inputs. So like a monkey, any kind of random inputs are given in order to check the system behavior, the software behavior, how it reacts, how it behaves. So we are basically checking the system, whether it is crashing, whether it is failing or not. So the main idea is to give random inputs in order to just find out it is crashing or not. So we don't need to create any kind of test cases here in this kind of testing. So it can be automated. Just write the program or a script and that can generate any kind of random inputs, and that can be given to the software product or the system. So this technique is very much useful or employed when we are performing the stress test or a load test. So monkey testing, just randomly giving any input in order to find out whether the system crashes or not, especially in stress and load testing. So we can divide this monkey testing broadly into two categories. One is smart monkeys and the other one is dumb monkeys. So smart monkey is a little bit having an idea. Dumb monkey has no idea about the software product. Okay. So smart is somewhat smart. It's not all smart. But brilliant monkey is very smart. He knows everything. He has all the documents. He has all the inputs. He knows the results also. So we'll be discussing about dumb monkey and smart monkey. The first is the smart monkey, the middle one. Now smart monkey has a fair bit of idea about the software application or the product. So he knows that while he is testing the websites, for example, he knows which page he is going to visit after this one. So navigation, he knows that. He also knows that the values he is putting, the input he is giving is valid or invalid. Now if any error he finds, the monkey, then he is smart enough to find a bug or a defect or a problem that he can do. That means he knows the navigation, he knows the menus, he knows the buttons. So he has a fair bit of idea about the application. But dumb monkey, he has no idea. He has no whatsoever idea about the application. Okay. They don't know that which page he is, on which page he is going to go. So he doesn't know from where he is starting, where he is going to end. He is just randomly giving input anywhere, anytime, any kind of input. So they don't know about the application, but we know we want this kind of dumb monkeys. Why? Because most of the people who are working on the software later on, they will be like this. So they will try to find out, and these errors, environmental failure or the hardware failures, can only be found out when you act as a dumb monkey. So they don't know about the functionality, they don't know about the user interface of an application. This normally happens when a user uses it and when the company people who the stakeholders are going to use it. What do you mean by gorilla testing in the context of quality assurance? Now gorilla, the animal, or you can say a chimp. Now how he is known to us? He is known to us about ferocity, doing things with all valor. So gorilla testing, this strength is why we are calling it as a gorilla testing. So gorilla testing is a technique, is a method of software testing in which very important is module. A module can be combination of classes, module can be even one class, module can be functions, module can be combination of functions. So a module, one module or a module is tested again and again. So some random inputs are being given and we are trying to find out the module's operation, checking it until we are satisfied there are no problems in the module. Okay. So we, as a gorilla, we are just giving random input because he's a gorilla. He will give the random input. But he'll do it again and again and again. Why? On a single module. So we call it as a torture testing. We call it as a fault tolerance testing. We also call it as a frustrating testing. Okay, because of the pattern the gorilla testing behaves or it's worked upon. So this is a manual test. Please remember, not automated. This is a manual test, and this is going again and again and again over, and this is done multiple times iteratively. So in gorilla testing, the testers and the developers, they work together. They do it just to ensure that or evaluate, determine the module's functionality through these all processes. Differentiate between gorilla testing and monkey testing. So there is a difference between a gorilla and a monkey as an animal. Same thing is applied here when we actually coin these kind of words. So gorilla testing is we are testing a module and we are trying to test the functionality. And here also in the like the monkey testing, we give the random inputs. We are just trying to make sure that the module operation is fine. We are checking a module and there is no problems in the module. So gorilla testing is just testing a module again and again with random inputs. In monkey testing, this is also a method of software testing, and we want to evaluate the behavior of the system. That is, here also we are giving the inputs, random inputs, but we are checking the behavior as the system or a software, it crashes or not. Because random inputs, there is no test cases we make here in the monkey testing, and we are just checking that it crashes or not. So this is done on the whole system software. Gorilla is done for a module. Okay. Now the monkey testing, we can make test script. We can automate the process because it is all about giving the random inputs. In gorilla testing, the primary idea of this kind of testing is whether a function is working properly or not. Monkey testing is whether a system or a software is crashing or not. What is its behavior on random inputs? Gorilla testing is manual testing. Here the developer and the tester, they meet and they work together repeatedly. Monkey testing, this is kind of a random testing and it does not involve any kind of test cases, and any tester can do it. Gorilla testing, it is just testing few modules. We are not testing whole software or whole system, just modules. Monkey testing, we are testing the whole entire system, whole of the software. Okay. So module can be a group of classes or for even a one function or a group of function. So unit testing, what we employ, what we do in the gorilla testing, because actually the testing of a component or a module is called unit testing only, done by the developer. Monkey testing is corresponding to the system testing. That is, whole of the software is made, any subsystem or any hardware or any kind of database is there, we combine and then we test for random input. So this is kind of a system testing, whereas gorilla testing is unit testing. There are different names of gorilla testing: torture testing, fault tolerance testing, frustrating testing. These are all a kind of gorilla testing. Monkey testing is also called as random testing, fuzz testing, stochastic testing. These are also the monkey testing only. If somebody asks you random testing, just answer monkey testing. Differentiate between quality assurance and quality control. So quality assurance is a bigger set. It corresponds to a whole organization or whole institution, and these will be they will make the standard, the process, how to actually do the things, what has to be incorporated. Quality control is implementing these standards or the way which is being guided by the quality assurance. So quality control comes under, or it is a subset of quality assurance. So in order to implement quality assurance, we do quality control. This is the main difference. But let us see more differences. See, quality assurance is a bigger set. Inside this, there is quality control. And inside this, we have testing. So quality assurance is a method that focuses on assuring that a specified quality which is being decided or which is being proposed is being met. That this quality we are ensuring. And quality control are the method to achieve this quality which is set in quality assurance. So on achieving, this is focusing, quality control is focusing on achieving the desired level of quality. Quality assurance, the idea or the goal is how to avoid defects. Quality control is to find the errors and to correct them. Quality assurance is a way of keeping track of quality. So it's a kind of verification, you say. So verification, quality assurance, quality control is validation. That is, it's a method of verifying the quality. Until you do certain quality control work like the inspection, like all these, how can you ensure? So quality assurance, it does not involve the product itself. That is, you don't run the product or do the testing, etc. Quality control, you are actually running the software or the product for every kind of test. Quality assurance is a kind of proactive measure. That is, this is the method of prevention. The organization make a quality plan, they make the standards, they have the, say, quality assurance, there's some standards, they have CMMI levels or ISO levels. And the quality control is a reactive measure. That is, something comes up, it is a remedial technique. That is how we control it at every juncture. Okay, that is how the testing comes under quality control. It is a part of quality control. Quality assurance, we are delivering to our users the quality product. And quality control is ensuring that the deliverables or the product are having that quality. So making it like quality standard meet, that can only be done using the quality control. Quality assurance is involved in entire software development process. Most of the time the quality plans are made way earlier in the SDLC. Quality control involved everywhere in the process, but mainly in the software testing or the hardware testing process. So quality control comes there because every time you need to check, inspect, and verify. So quality assurance is at the say organization level. So it establishes the standards and the processes in order to achieve the client expectation, what the user wants. So it is kind of ensuring that, okay, we are going to give you this. Quality control, while we are actually working on the product, it ensures that the standards being followed in quality assurance are being followed here. So quality assurance is a bigger set. It has to be done prior to quality control, and quality control is of course done after the QA is being established, and in order to implement that QA, QC is done. What do we understand about data-driven testing? So data-driven testing, this is a kind of software testing that store the test data. Just assume that we have a table. Table is just rows and column. It is a table or a spreadsheet. So now the data, which is a test data in the table or a spreadsheet, is the test data which is stored here. Now tester can do what? They can use this data driven testing to enter a single test script that can run test for all test data from the table. So in a table there are rows and columns, so you can just multiply a number of rows and columns and know how many values are there. Each of the value, a test script can be written. Each of the value can be the entry, and we can look for what is the result coming. What is the difference between the expected result and the actual result? This is also known as parameterized testing and table driven testing, because testers usually have several data sets for a single test. Here data driven testing becomes critical, because creating different tests for each data set can be very time consuming. So data driven testing allows data to be kept separate from the test script. So data is different, test script is different. Generally, the tester do what? They have data and script together. So this is different now. And the same test script can be run for multiple combination of input test data. Just assume that we have multiple tables. Multiple tables have multiple data. So one input for that one input table gives result, other give result. So this is more efficient test result. So you see in the picture, here we have a data file. Data file means it's just like spreadsheet or table. So this test data, here you have a table here, multiple tables that contains your input data for testing. Now we have a driver or a script. You can just write a C program or just like that, okay, or in any automated tool. Now this data file is the input for this driver or a script, and this is given to the application under test, and here you get the actual output. In the data file, it is already there. Just let me show you a box here, a cell. So in this cell, you have the test input, you have the expected output, and then it comes the actual output. So here in one go, you know that what is the expected output, what is the actual output. So this is the beauty, this is the power of data-driven testing framework. Rather than doing it all, use the driven test table. How do you ensure that your testing is thorough and comprehensive? Now testing never ends and it cannot be comprehensive. But only thing is you are transferring the testing from your end to the user end. When you are deploying or giving the software, you're actually giving him so that he finds out the bugs. Or you can say when the cost and the budget or the time it ends, the testing is over. But still, in order to answer this question, we have certain data structures, certain formats in our documents. The first one is RTM, Requirement Traceability Matrix. The second one is Test Coverage Matrix. So these both will assist us in finding or determining whether or not our test cases are adequately covered or fully covered, comprehensively covered. So the Requirement Traceability Matrix will assist in determining, we have a requirement specification. So whether the test conditions are sufficient to fulfill all the requirements which are given in your SRS, Software Requirement Specification. Now coming to the coverage matrix, this is going to assist us in determining whether the test cases are sufficient to satisfy all the requirement traceability matrix test conditions. That is the test condition which are given in the RTM, whether these test condition are the coverage is whole for that condition which is given in the RTM. So for the test TCM, the input is RTM. For RTM, the input is SRS. Okay. So this is how we can say we have done it comprehensively or thoroughly. This can be the only answer. What do you understand about regression testing? Which test cases should be selected for regression testing? Regression testing is all related with one word: change, modification. So regression testing, whenever you change, you will do the regression testing every time. That is why it's most expensive, most employed testing in the whole testing community or field. Maintenance time, 67% of the time we do maintenance, and most of the time we do the regression testing. So regression testing is a software testing technique. When we change a program or there is a recent change or modification in the program or a code, now we need to ensure that it hasn't broken existing functionality. It has not created any more bugs. It has not created any more kind of defect. So regression testing is just a full or a partial. See, you can retest all. You have a test set, 100 test sets. So we can test all. We can prioritize. Oh, these 10 I will do. Or a regression test selection, 20 I have taken, and I'll always do this in the regression test selection. Every time this 20 can change. So regression testing is just a full or partial execution of previously executed test cases. That is the test case set to confirm that the current functionality is working properly. There is no change because of the code modification. This testing ensures new code modification have not created unintended consequences for current functionality. So we want to ensure quality and functionality remains the same. So it ensures that old code continues to function after the most recent code modification. So what we see as for industry data, large portion of the defects reported by the customer, we just do it bug fixing. We just do the patching work. So that may create some inadvertent or unintended consequences, making selecting the test case for regression testing a very good art, not a very easy task. Okay, because that functionality has to be checked. So we have test scenarios that can be used to create effective regression test. The test scenario with high number of problems, defect or the flaws. Test cases covering features that are more visible to the user. Test cases that test the programs or products fundamental feature. Test cases of functionality that have experienced significant and recent changes or alteration. All test cases for integration, all complex test cases, and cases of boundary value tests. What do you understand about severity and priority of a defect in the context of quality assurance? Differentiate between them. So the word, if you know the meaning of severity and priority, that says it all. So a defect, how much severe it is, how much it is going to affect your software or functionality. Priority is what has to be done first, what has to be done later. So you know the problem, but severity, I'll tell you what are the levels just now. So severity is a metric. So the severity of a flaw or a problem or a bug is defined as the degree to which it can affect the software. Okay. So the severity is all about how much it is going to badly affect the software. So if I give a number 100 to defect, so if it is affecting 40% degree, so what is the severity? But if I give 80 to this 100, the severity is high as compared to 40. So the severity of a defect is a metric, is a number that indicate how serious it is and how much it is going to affect the software's functionality, software quality, and software status in the eyes of your users. Okay. So this is the severity. It's all about how much it is going to affect the functionality. Priority is a parameter, is a value or a way to determine which defect should be addressed in which order. If we have 10 defects, first we will do this, second, and then 10th we will do this. The higher priority defects should be addressed first. And these listing is only done with respect to the severity, of course. So severity of let us see the proper differences. The severity of a software defect or a flaw is a measure that indicate how serious it is, how seriously it is going to impact our software and software quality. Priority is a criteria used to determine which defects should be addressed first and which defects can be done later. Severity, the degree of severity, is directly proportional to the quality standard. If the severity of defect is higher, it is going to deteriorate the quality if you are not going to address it. There are certain flaws which may not impact quality as such. Priority is linked with the timetable for resolving the issue. First we will do this, the second you will do this, the 10th one will do last, like this. Okay. And mainly this listing will be done with respect to quality only. In severity, the defect severity level is determined by the testing engineer. The priority is generally defined by the product manager. Because severity is more related to quality, it is done by the testing one. The severity of a fault refers to how much it affects the functionality. So, as I said, the functionality of the software. So, the priority is just how quickly we are going to remove the defect, which needs to be fixed first, which can be done later. So severity, it has objective worth. I'll just tell you what it is. Priority its worth is a matter of opinion. The project manager thinks, okay, this has to be done first, this has to be done later. But it has objective worth, means it is directly affecting the software. It can fail the software, severity is high. It is directly exposing the quality. Okay. So the priority may be on the user expectation. Oh, we have to do this, so let us do it first. Severity, see, severity can be performance issue. It can be at that issue which is more important than any other functionality, or the severity remains constant over time. If a flaw or a problem is severe, it will always be severe. It is less severe, it will always be less severe. The priority, see, I'll give you an example of severity also. You know, in an aircraft, if a simple C code, if you know about the Boeing A370s or 350s, I guess, 2 or 3 aircraft, there was a nose up, fixing of a code. Okay. And because of the nose dive, many people, 400, 500 people died in different catastrophic accidents. So severity remains always constant. But priority changes. If user wants that 10th number has to be done first, it will be done first. It depends on all, about the way the software or function is working. The severity can be critical, major, moderate, minor, cosmetic. Let me tell again about the priority: low, medium, high. These are the levels. What do you understand by black box and white box testing? Differentiate between them. So in black box testing, the internal structure, the internal code is not known to you. In white box, you are aware of how the code is written, what is inside. So the looping, the structure, the constructs, all is known to you. So black box testing, the implementation knowledge is not required, because you are just going to check the functionality. In implementation, in the white box testing, the implementation knowledge is really required. Without that, you will not be able to do it. There are different names for black box testing. It is called closed box testing, data driven testing, and functional testing. Like this functional testing is used more than black box testing. Then white box testing, we have clear box testing, structural testing, and code based testing. In the black box testing, it is performed by even the user, because they can check the functionality, or software tester. But the white box testing, it is normally done by the software developer, because you need to know the code program, then only you can do it. Basis part testing, etc. So programming knowledge is not required in black box, and white box programming knowledge is required. So what are the types of testing which is there in black box testing? For example, you have a code. Now, when you just write a code, you want it as a function. Now you will check it. That is, the input is going and output is coming. So you can call it as a module also, or a component also. So that is unit testing. So the black box testing and white box testing. Here when we combine the modules, different modules, so we check the interface testing. So this also comes under white box testing. So the unit testing, when you write a code, or module testing, or interfacing, that is the testing of interfacing, that also comes under the white box testing. So we have path testing, loop testing, conditional testing. This is all comes under the white box testing. But the low level testing is all what we call as white box testing, because you have to go to the code level and then you have to check. But you just have to check the function now. So if you are putting 2 and 3, if you want to check the add function, if 5 is coming, it's okay for you. So this is the functional testing. So functional testing, non-functional testing, and regression testing, they all comes under the black box testing. So these are the major differences between them. What do you understand about bug or defect triage in the context of quality assurance. Bug, defect, flaw, problem. In defect triage, the defect or the problem is reviewed. Then this defect is assessed. There is a proper assessment being done. And finally, we assign, say maybe resources we assign like that. So defect triage is a method of prioritizing bugs based on the severity, the frequency with which it happens, the risk, and there are other factors also. So these are different factors on the basis of which the priority of these bugs or flaws are given. The term triage or triage is used in software testing and quality assurance to describe the severity and the importance of new faults. New fault has come, new bug has come, so we have to assign a number. We have to assign the severity. So in this software testing and quality assurance, we assign a severity and according to the importance. Now, bug triage, the purpose is, as I said, just reviewing and prioritizing and then assigning the defect solutions to it. So team must confirm the severity of the fault, then need to make the certain changes, necessary changes, conclude the defect resolution, and then we assign the resources. So this kind of method or defect triage is normally used in agile project management. So depending upon the severity, the resources are assigned. So agile project management, we have to know the severity first. So the frequency of these defect triage meeting is also one of the aspects. It totally depends on the circumstances of the project. So what kind of circumstances a project may be in, then we have this meeting normally in the agile project management. So let me tell you the key elements of this meeting that influence the frequency of these defect triage meetings. First of all, maybe it is according to the product schedule or the number of flaws or problems or defects which are upcoming, and the impact on the availability of team members' schedules. Those who have found out the error, those who are going to fix the error, and the state of the project as a whole. The project may be at the inception stage, it may be at the delivery stage, that is. What do you understand about stubs and drivers? Differentiate between them. So I'll give you a very naive way to understand it. We'll take an example also. But here, that you have say a module, there are 3 modules. Okay. Now one module is calling the other and the second module is calling the third one. Now in case this module, the last module, is not yet being prepared, so we'll make a dummy program, and this program, dummy program, is called the stub. This is one scenario. Now this may happen that the main module which is calling the other modules, this is not developed. There may be circumstances. For that, we will make the driver program. So this driver is the main module. Stubs are the called module. So these stubs and drivers, mainly when we have sub modules for them, if they are not prepared, they are called stubs. But the major module, if it is not prepared and there are the low level modules are being created, then what we do? Then we have to make any module that will call them. So that is called the driver. Driver is the main program or main module. Stubs are the called modules. Okay. Please remember that we have a login, we have a home or a user. Now what happens here is the login is ready for the testing. The home and the user, these modules are not ready. So login module has to be tested, but without this home and user we cannot check. So for home and user we'll just write few line of code that will just emulate, mimic, and finally once the testing is done, we will throw that code. Okay, I hope the driver and the stub code will eventually be thrown away. They are just written for testing. So stub, when we are doing the top-down testing, is required. When we are going for bottom-up, we require driver. So there are certain unforeseen circumstances where the high-level module or the module which is calling other modules is not prepared. The lower level modules are already being made. For that, we have to write the driver. Let us take this example again. So user and home are made now, but the login module is not yet prepared. So we have to write a simple code just mimicking or emulating this main module. That is called the driver. Stubs and driver. The difference between them is, let me tell you again, that there are modules at the higher level, there are modules at the lower level. So the lower modules are called by the higher modules, or the functions are called by the higher functions. So these are the submodules. When the submodules are, if the submodules are not ready and we need them to be called in order to check the main module, for that we'll write stubs. Okay, we will not write any functionality. We will just try to write 2-3 lines just to emulate that, okay, this is being called, because we are eventually checking the main module. And similarly, when the main thing, the lower modules are ready, upper module is not ready, upper module will be called as driver when it is made. So top-down integration testing, stubs are employed. In bottom-up integration testing, drivers are used, and they are simple code which will be thrown away eventually. So we are just mimicking, we are just trying to write code so that the testing can be done. Stubs are analogous to software modules that are in the development stage, and drivers, they are not, these drivers are not, the stubs are not being made, right? They are just modules which are not being made. But drivers are accustomed to invoking the component that must be tested. So for that, we have to write a driver because it is calling modules, and those modules have to be checked. Okay. So these stub, they are also called as called programs. Stub are called programs or called modules or called functions, and driver is called as the calling program. You know the difference now. Calling program means it has to be above the lower level module. So it is calling program, and stubs are called. So that is called, they are called call program. Okay. To test the feature and functionality of the modules, stubs are used. If the core module of the software is not developed for testing for any reason, the drivers are used. So whatever I have told you is all about the upper level module and lower level module. Upper level module is completed, lower level module are not completed. You have to make stub. Otherwise, you have to make driver. What is the rule of a test-driven development? So in the test-driven development, what we generally do, we write the code and then we test. So in between, we may write the test cases. The cyclomatic complexity we compute, that gives the upper bound of the number of test cases. So then we just write the test code and test cases, and then we test. In the test-driven development, the things are different. Before even writing the actual code, we prepare the test cases. The only difference is that the test cases are prepared before, written before writing the actual code in the test-driven development. For example, if a code, you know already that these are the passing parameters. You already know that these are the acceptance testing scenario. So when you know that these are kind of a test we have to pass, so we make the test cases earlier, before making the code, because we will make the code in accordance with these test cases so that we can pass the final test cases. So we write the test cases, execute the test cases. If the case fails, then the changes are made to make it correct, and then we repeat the process. This is the TDDC, test driven development cycle. What is ad hoc testing? Ad hoc means, for example, in your college, there are certain teachers who are or professors which are permanent. There are someone who are just, you can say, called in agreement or contractual basis. They are ad hoc. So you can relate with that. Ad hoc testing is an informal way of testing. That means it has no formal way. In a formal way, we will first write the SRS, then design, then we write the test strategy will be defined, test plan will be defined, test cases will be written. All this is a formal way. But in ad hoc testing, there is no formal way, no requirement documents, no test plans, no test cases. So the characteristics of ad hoc testing is performed after all the formal testing is done. Because our main aim is to break the software by any means. Ad hoc means doing everything which is possible. So the testers who are executing the ad hoc testing, they should have a deep knowledge of the product. So even you can give it to a naive also. Because no documentation, no test design, no test case, anyone can check. You just have to break the system. How is ad hoc testing different from exploratory testing? See, exploratory testing is learning testing. In ad hoc testing, you test in order to break the system or a software. After all the testing is being done, exploratory testing is starting from the scratch and trying to learn the software by testing. So in ad hoc testing is the testing of software without any documentation or requirement specification. Exploratory testing, the knowledge about the software while exploring the application. That is step by step, you learn the software while testing. Because when we go on a way and we don't know the path, we just say we are exploring. So we learn the software by means of this testing, and that is called the exploratory testing. You are finding the ways by yourself. So ad hoc testing, I told you that there is no, because it is informal. So documentation is not required. Exploratory testing, documentation is mandatory. Ad hoc testing, the main aim of ad hoc testing is to achieve the perfection in testing. Because all the other testing has already been done. Now you are doing everything to break the software. So you are trying to achieve the perfection in testing. Okay, we do everything which is possible. We need to crash or break the software. In exploratory testing, the main idea is to learn the application, to understand the application, to gain knowledge about what is happening by the means of testing. Ad hoc testing is an informal approach, but exploratory testing is totally formal approach. Because we are stepwise learning through testing. Ad hoc testing does not require an expert testing engineer, as I said. That is, whatever you want to give, you give. This is ad hoc. Because maybe some click or some combination of keys can break your software. Exploratory testing does not require an expert testing engineer. Because even if you are, because this is a learning curve. Anybody can do this exploratory testing. It is just learning about what is happening in the software through testing. So this is the difference between ad hoc and exploratory testing. That is, okay, this is the way exploratory is. This is the way. Oh, from here, oh, this is the new way. So we start learning. What are the different levels of software testing? See, software testing, there are two types of software testing: functional testing, non-functional testing. But when we are talking about levels, say you have started writing code just now. You will write 4 or 5 lines or maybe 10 lines or 40 lines in a day. So let us say that you have these 40 lines is a function. So you will check these function, that is the unit testing. Now next day you wrote one more function, or you can say 2 modules are being made in few days. Now you are combining them, and that combination and then checking, that is called integration testing. Now you have created all the modules, the software is ready. Now it has to be checked with all the other systems which are working it with your software system. That is called the system testing. Actual testing after the system is actually being created. And finally, the user will test. That is called the acceptance testing. So alpha and beta testing. This kind of testings are acceptance testing. So there are 4 different levels in software testing: unit, component testing, integration testing, system testing, and acceptance testing. Unit testing. So as I said, this is the lowest level in the testing level, lowest level. Unit can be even programs, even can be modules or the components, and because they have to give certain result. Unit testing is performed by the programmer because he knows about the modules, he has written the module, and any function, any problem is there, he will fix instantaneously. So once the unit testing is done, we go for integration testing, because now the modules are being created, few modules, and now you combine them. So we have to see the interfacing, that how this integration testing is all about how the data is flowing from one module to another. So collaboration, interdependency, interface testing. So we are checking the communication between multiple modules. We don't check the functionality of individual modules. That is done in unit testing. So this is the integration testing. Then the system is finally complete. So system testing is used to test the complete or integrated system. So it is basically related to SRS, software requirement specification, that all the requirements are being completed, and this is the system testing. And as I said, both functional and non-functional testing is performed as a part of system testing. And finally is the acceptance testing, and this is performed by the users or the stakeholder, the customer. Now I'll tell you alpha and beta testing here. The difference, just see the difference. See, if alpha testing, beta testing, see, first of all, alpha testing is that you are going to the developer place, because developer is controlling the environment now, and you are testing your code, your software. That is called the alpha testing. Now the software is tested at your end, at your environment. The developer has no control over this environment. That is called the beta testing. What do you mean by quality audit in the context of quality assurance? So quality audit, see, audit is all about checking, verifying, and inspection, examination. Just say you have a company, you have a balance sheet, and then some money you sell, some product you sold, some product you buy. There is a whole dollar amount which you know. Now, if your company is big, how to know that things are going fine? No forged bill is produced, like that. Money is going every good way, or the income tax is being filed. So for that, audit is done. So same way, in order to ensure the quality audit is done. So there will be an audit is an on-site verification activity of a processor quality system, like the inspection or examination. It can be an internal or an external quality auditor, or even can an audit team can be there. It conducts a systematic analysis of quality system as a part of quality audit under quality assurance. So quality audits are conducted at predetermined intervals to ensure that the institutional internal system monitoring methods are well defined and linked to successful action. So audits are an important management tool for confirming objective proof of processes for quality assurance, quality control, and the testing. So any problem will come out. For this, quality audit, all the process is basically producing a report that these things are not followed and you need to work on it. So in order to ensure quality assurance, we need to seriously take the quality audit report. Okay, let me tell you in another way also. Let me clean it. See, quality audit is verification effort aimed at determining the degree of compliance of a product, design, or a process or a system to a standard specification or procedure which is already defined in quality assurance. So the quality audit includes two parts. The first is the examination of the system, in which the product or services are created, known as the quality system audit. The other is a product or service quality audit, which is examination of product themselves. The first is the product and services, that is the processes. Second is actually checking the product or the service, means actual examination. Okay, this is all about this discussion. Thank you so much.